So in order to solve this for x, we want to start by making it look like something that we're more used to. Now, if it was just a single fraction on the left-hand side, we could deal with that. So the first thing I want to do is actually make that into a single fraction on that left side. So I want to do the 1 over x plus 2 over x. So I'm doing addition. That means I need a common denominator. Thankfully, we already have a common denominator, so I can go ahead and just do that addition. So we end up with 3 over x equals 1/4. Well, then you know how to solve that, right? We have a fraction equal to a fraction. That tells us to cross multiply. So I'm going to do x times 1, which is going to give me an x. And then that's going to be equal to, please remember that when we cross multiply, the two are set equal to each other. We get rid of all fractions. I cross multiply the other way. I do the 3 times 4, which gives me 12. So x equals 12, and thankfully that's all we have to do on this one. We have our final answer. This is really all we're doing today. It's just we're going to be looking at different and, of course, a few more complicated variations of this. But the whole idea is still always going to be the same. Anytime you have a whole bunch of fractions involved and you're trying to solve the equation, go ahead and just start by making it a single fraction equal to a single fraction, and then we can cross multiply to solve. We're going to be applying that to this problem next. So go ahead and write down this problem, and then start by doing the addition on the left-hand side. Now, when doing that addition, what do we always need in order to add the fractions? Common denominator, yeah. So my current denominators are 2 and x. What should I make my common denominator become then? 2x, yeah. So in order to get there, that means I'm going to have to multiply the bottom of the first by x, so that means I'm going to have to multiply the top by x. And the second fraction, in order to turn that into a 2x, I'm going to have to multiply top and bottom there by 2. When you get your common denominator, this is what you should be looking at. X over 2x plus 20 over 2x equals x over 2. Now we can actually do the addition. Now, of course, we know what the denominator is going to be. We know it's going to be over 2x. But what is on the top? When we actually add those, what does that give us? And I ask very purposefully because I get two different answers from people on that. Some people tell me it's 20x, and some people tell me it's x plus 20. Well, are they like terms? No. Because the x, of course, has an x in it, and the 20 does not have an x in it. Therefore, I cannot add them. The best I can do is actually just to write that top is x plus 20. If you write 20x, what you're actually saying is 20 times x, not 20 plus x. And now that we have a proportion, that is a fraction set equal to a fraction, go ahead and cross multiply. So go ahead and pick it up from there now. Now when we do that cross multiplying, we're going to do 2x times x. Yes, we can multiply them. That's going to give us 2x squared. Then that's going to be equal to, go ahead and cross multiply them the other way. When you do the x plus 20 times 2, remember to distribute the 2 to both the x and the 20. So that's going to end up giving us 2x plus a 40 there. And so now we take a look at our situation. After we've cross multiplied, now we can start strategizing, how do I solve this particular type of equation that I've been left with? And notice the distinctives about this particular equation. We have an x squared term, and we have an x term. Because we have one of each of those, that tells me that I'm going to be trying to factor in order to be able to solve it. And in order to factor it, I have to have it set equal to 0 first. So since there's a bit of work left to do on this, I made some more room. And since I want it equal to 0, I'm going to move everything to the same side. Since I want to keep the x squared positive, I'm going to subtract the 2x from both sides, and then I'm going to subtract the 40 from both sides. That way I kept the x squared term positive. Now that it's set equal to 0, I can worry about factoring. So go ahead and factor from there. So in order to factor it now, I notice that I can divide everything through by that 2 that's out front of the x squared. So I'm going to do that first to make it a bit easier. Now, technically speaking, you could actually divide both sides by 2 because it equals 0. But because people so often try to divide everything by 2 and not leave it out front when they have to leave it out front, that is when we don't have it equal to something, I would recommend that you look at it as factoring it out, because that way we don't run into that mistake. Now that we have the x squared minus x minus 20 inside, we can factor that. So we're saying what adds to negative 1 multiplies to negative 20, negative 5 and 4, yep. And so write the factored form. Make sure you write the factored form before giving the answer. Otherwise, you might forget to flip the signs. Because remember, I'm saying what minus 5 equals 0. That's why it's a positive 5. And what plus 4 equals 0. That's why it's negative 4. Now, notice we ended up with multiple solutions here. In the past, when we've ended up with problems that have multiple solutions, we've sometimes found that they can be extraneous solutions. There can actually be extraneous solutions with these as well. So I don't really want to have to go back and plug both of those numbers into that whole big original equation, because that thing was pretty big and it's kind of a pain. So an easier way is actually go back to the idea of the restrictions. Take a look back at the fractions that we had up above. What could I plug in for x there that would make the denominator equal 0? 0. Yeah, because 2 times what is 0? It's 0. So if I were writing the restrictions, which you don't have to write it out for this, but if I were writing out the restrictions, it'd be x cannot equal 0. Notice neither of our two solutions is 0. So that means they're both going to be okay. Both of those are valid solutions. Now, if one of those was 0, then it'd be an extraneous solution. So once we get our answers, we then just go back and check and make sure that neither of our answers was one of the restrictions for the problem. That being done, we're going to do one last problem. And this one problem really is kind of a culmination of everything that we've done up to this point in this unit. You're going to use almost every single skill. So just like the previous problems that we were doing, step 1, do the subtraction. Make that a single fraction on that side. So of course that means in order to do the subtraction, you're going to need a common denominator. So in order to do the subtraction and get that common denominator, I'm going to need to multiply this first fraction, top and bottom, by the x plus 2. So that one gets multiplied top and bottom by x plus 2. The other fraction, in order to get the common denominator, I got to multiply by the other denominator, which was x minus 8. So I multiply top and bottom of both of those fractions accordingly. This is what we're then going to end up with. Now, I've done a lot of these problems. I know where we're heading with this work, so I went ahead and expanded the bottoms. However, you didn't have to at this point. All the problems we've done before, we left the bottom factored. So if you wrote this as over x minus 8 times x plus 2, that's perfectly fine. Just realize that we will hit a certain point where we will expand it. But that's because of stuff we're going to be doing with this, and it becomes more apparent later. So if you want to wait until it proves itself to be necessary, feel free to do so. You can leave it factored until then. Because the next thing we're going to do is we do the subtraction, which means subtracting along the top. Whatever the bottom is, as long as it's the same, we can do that. But I want to make sure that we don't make a very common mistake here. When I'm doing that subtraction, the 5x minus 3x, that's fairly straightforward. 5x minus 3x is going to be 2x. We're generally pretty reliable with that. It's the next one, though, where we tend to make a mistake if we're not careful. Because when I do the 10 and the 24, put those together, it's not going to be negative 14. But a lot of people think it is because we see 10 minus 24. But we aren't doing 10 minus 24. We're doing 10 minus negative 24. So 10 minus negative 24, that's the same as 10 plus 34. I'm sorry, 10 plus 24, which gives us 34. So it's actually 2x plus 34 on the top there. And of course the bottom stays the same. Yes, you could still be writing the bottom in factored form at this point. I just happen to have chosen to expand it out. So now I've got a fraction equal to a fraction. Once I've gotten to this point, what do? Cross multiply. Thank goodness the top of that other one is a 1. It's going to make that a lot easier. Go ahead and cross multiply those. Now, if you'd been leaving it in factored form in the denominator instead of expanded form, you would end up with something that looks like this at this point. And this is still technically correct. This line is fine if you wrote it that way. The only problem is that from here, it's kind of unclear what we do at this point. So if you left it in factored form, which was fine to this point, we are now at the point where we're going to have to expand it out. So if you have not yet already multiplied these out, multiply everything in the first parenthesis by everything in the second parenthesis, so that we can then see what each of those expands to be. When you do that, this is what you should be looking at. 2x squared plus 38x plus 68 equals x squared minus 6x minus 16. The reason why we have to expand it out here is because now I'm going to try to move everything to the same side of the equation, set it equal to 0, and we couldn't do that before when it was all just the messy parentheses. Well, we could, but it wouldn't be very pretty or useful. Now, since I'm trying to get this to equal 0, that means we're moving this stuff over with addition and subtraction. Every now and then somebody will think, well, can I divide? Technically, you can divide some of the things, but it's not going to leave you with 0 when you divide something by itself. The only way to do that is subtracting. So I'm going to subtract x squared from both sides. I'm going to have to add 6x to both sides. And we're going to have to add 16 to both sides. When you do that, you end up with x squared plus 44x plus 84 equals 0. And now that it's equal to 0, we can try to factor it. So find out, are there two numbers that add to 44 and multiply to 84? And there are two such numbers. What adds to 44 and multiplies to 84? 42 and 2. Yeah. And so now that I have it in factored form, I know that equals 0, so I set each of those two parentheses equal to 0. So what plus 44 equals 0? Negative 42. Okay, what plus 42 equals 0? Yep. And then what plus 2 equals 0? That'd be a negative 2. So you don't strictly have to write this as you go, but it's good to put it down at some point just so you can keep track of it. We know that the restrictions for this problem would be that x cannot equal 8 or negative 2. So then the reason why I made note of that is because I now want to compare it to my answers here. You notice something there? That negative 2, right? That's an issue. So because the negative 2 is one of the restrictions, we're saying that in this problem, x could not equal negative 2. That means the negative 2 we found in our solution process was extraneous. So the only actual answer is that x equals negative 42. And only negative 42. So the whole idea is that after you get your solutions, then you just check and make sure that neither of those solutions was a restriction. Now, why do we have to worry about it? Because notice if I took that negative 2 and plugged it back in for x up here, I'd end up with, for instance, let's take a look at that fraction right there. That becomes 3 over 0 when I plug negative 2 in, because negative 2 plus 2 is 0. And 3 over 0, remember, is undefined. Basically, it breaks it. It's impossible to do math on undefined. So anytime you find that it would result in dividing by 0, you know that it's impossible to do mathematically. So that's what we got to account for.